Hello EFR 515 students. This is chapter 16 in our text, Introduction to Regression. And we're going to go through a couple examples. Linear regression, very important to us. And it's used a lot and it's related to correlation, which we've done in previous chapter. So we're going to go through these examples. So the first one says, enter the data below in SPSS. Conduct a simple regression analysis predicting y from x. Use your output to write your regression equation. Test to see if there is evidence that your slope b is different from 0. This is a null, that it's 0. Write up your results in APA. Use type 1 error rate of 0.05 to evaluate your test. Also write out your regression equation. So for this example, we're going to use the data from page 563, example 16.1 in the text. And we'll go ahead and run this analysis. So first thing I'm going to do is bring it over to SPSS over here. So I'm just going to copy the actual data. I could copy observations as well, but that's not necessary. So I'm going to bring that up. Make sure I'm in data view, and I'll go ahead and paste my data in there. And then down below here, I'm going to go to variable view, and I had X. I'm going to label that X, and then Y. And now my data is in. I don't need those. I just hit something I didn't need here. Okay, so my data is in. I'm going to go back to data view, and here's X and Y in the equation. So we'll go ahead and just run this then. And to do this, I'm going to go to Analyze, Regression, and I'm going to go Linear Regression. And that's linear in the parameters. The independent variable here is X, so I'm going to click on X, bump that into the independent, and the dependent variable is Y, because I'm trying to predict Y with X in the equation. And for now, that's all we need in our analysis. Obviously, there's some options we could work in over here and plots of residuals and alike, but that's all we need for now. So I'm going to go ahead and just say OK, and that's going to bring up my results in my tables. So I'm going to go ahead and move this over. Here, I'm going to grab it. Okay, so it'd probably be good that you bring in these tables into the analysis. So we really need this, the one we need to bring in specifically is, let's look at the model summary. So I'll copy that over. Oops, didn't work. Should just click on it, copy. I should be able to paste that in. Likewise, I'll bring over the ANOVA, copy, paste that in, and correlation coefficients, copy, and paste that in. Okay. All right, so for the first problem, that's all we need really from the analysis. So let's broaden this out. All right, so in the regression, this first table, model summary, it's giving us our R, giving us our R squared, adjusted R, and standard error. So the R is just our correlation. Because we have two variables, what's called simple regression, this is the same thing as our Pearson correlation that we had before. If we square R, our coefficient of determination, that's telling us the percent of variation about the mean explained by the model. So we're explaining about 56% of the variation in Y can be explained by the linear model that we're using in this analysis. Come down to the ANOVA table. Because we have simple regression, for the actual variable here, X, and the regression model, they'll be the same, so 0.32, 0.32. And it's important here because we're getting our error here, our degrees of freedom error here, 7. So then we'll look at the coefficients. In our model for the analysis, what we had up here for the simple regression is y prime, and it's a little caret above. I can't write that easily on my text, so go ahead and write y prime equals bx plus a, where b is our slope, and x is the actual representation of the variable, and a is the intercept. So here, in essence, here's our b's, and this is this 4.40 here. So this is a right here. Okay, and then this is b right there. So in our analysis, that's working in our equation. We'd pull those down into that. So we can end up with our equation here, y prime equals, we'll pull that b down, which happened to be just 1, times x plus the constant, 4. And that's the equation we need to write out here in this case. So any value put into x, it would predict some y value in this regression. Now, as far as statistical significance, what we're testing here is the slope. We want to know if that slope equal to 0 or not. So we'll talk about if we're just using our constant here, it's a t value. We get that right here. So it's a t. Its degrees of freedom is coming from the ANOVA table up here for the residual. Now residual or error, so it's coming right here, 6. Oops, I shouldn't have wrote that there. So it's a t with 6 degrees of freedom. Its value, and this should be a t here, its value here is 2.777. So 2.77, we'll go ahead and write all the sigs here, comma, and then the p-value, p, and what we need to know is it greater than or less than 0.05. And here we're seeing it's less than 0.05. So p less than 0.05. And again, if a number can't be larger than 1 in APA, doesn't get a 0 in front of it. So it's a t with 6 degrees of freedom, 2.7, and p less than 0.01. So we see that it is statistically significant at the 0.05 level. And what we're seeing here then is that the equation here, y prime equals 1 times x plus 4, and it is statistically significant with a t of 6 equal to 2.777, comma p less than 0.05. So and that completes the analysis for problem 1. Now let's go on to problem 2, right here. And here we have a multiple regression. So we're going to run a similar regression, but here we have two independent variables, x1 and x2. So the process is the same. We'll go ahead and go over to SPSS. And I'm just going to go ahead and go File, New, Data. Okay. Won't give me my new data set. So I'm going to delete this current data in here then. Just clear that. Because I'm in multiple screens here. So I just cleared the data. Often it's easier, just create a new file and close the old one. So under Data View, I'm going to go ahead and just grab the data. Bring it on over to my file, making sure I'm in Data View. I'm going to paste the data in there. You could type it in by hand as well. Now I'm going to go to Variable View and name the variables. And that was Y, X1, and X2, just like we did before. Okay, so we're ready to run this analysis. I said just run a regression analysis. Test each of the slopes for 0, not, and go ahead and write the equation. So in SPSS then, I'm going to go Analyze, Regression, Linear. My dependent variable is Y, and my two independent variables are X1 and X2. Once that's in, I'll just go ahead and say OK. And You'll have to go find your output. Okay, so here's my output. So I'm going to go ahead, and I'd like you to do this as well. Let's go ahead, just bring this right into your assignment so I can see what's happening in your assignment. So we'll bring in the model summary. Again, I'm just copying them over. The ANOVA table. And then finally the coefficient table. Okay. Now here we're looking at similar things. In essence, is the R squared here was 0.577. Again, that's coefficient of variation, telling me what the model's explaining here. And it's showing me the model, the ANOVA table. In the ANOVA table, now that it's a multiple regression, that this is the overall or the omnibus test for the regression, and here's the individual items for the regression. So we really want to focus on our degrees of freedom here, which is 7, and then our coefficients here for the model. So we'll go ahead and first off we'll write the model. So it's y prime equals, and the first value for x1. Here, let me pull the model down up on top here that I asked you to write, so we know where we're getting this from. Okay, so when we're looking at this, the constant, again, this is A here. This is B1 here, and this is B2. Okay, so we just got to transplant that down below to write out our linear equation. So in the first case, B1 is 0.67 here. Actually 0.672 times x1 plus then 0.293 times x2 plus, and then the constant or the intercept, which is 2.552. That's our equation. And then what we're testing in this case is each of the slopes, B1 and B2. Under the null, that we're assuming they're 0, on the alternative we're not. So we're coming across here, it's a t. We see up here it's a t-test. So in the case of B1, it's a t. It's a t with, we're getting from our ANOVA table, our residual term up here, our error term, so it's 7. Its value is equal to 1.652, comma, then p is greater than 0.05. We see right here our sig value. This is greater than 0.05, and here was our t value. So now we'll go ahead and just do that for B2. We get a t with 7 degrees of freedom. It's equal to 0.732, comma, p is greater than 0.05. So we see in this case that neither of the coefficients here for our slopes are statistically significant in this analysis. So that covers this analysis. We're getting the context in the text. So good luck with the actual assignment.